Big Bang Theory. The Big Bang Theory describes the universe beginning as an extremely hot and dense point that rapidly expanded. Over time, this expansion cooled, allowing matter to form, then stars, galaxies, and everything we see today. The idea comes from observations like galaxies moving away from each other and the faint background radiation left over from that early moment. It remains the most widely accepted explanation because it matches what astronomers continue to observe in space. Steady-state theory. The steady-state theory suggests that the universe has always existed in roughly the same form with no true beginning. As it expands, new matter is constantly created to keep the overall density the same. This idea was popular in the mid-20th century because it avoided the need for a starting point. However, discoveries like cosmic background radiation gradually led scientists to move away from it. Oscillating universe theory. The oscillating universe theory proposes that the universe goes through endless cycles of expansion and contraction. After expanding, gravity eventually pulls everything back together into a dense state, which then triggers another expansion. This creates a repeating pattern of beginnings and endings. It offers a way to imagine a universe without a single starting moment, but current observations suggest the expansion may not reverse. Inflation theory. The inflation theory focuses on what happened just after the universe began, suggesting a brief period of extremely rapid expansion. In a tiny fraction of a second, the universe grew much larger, smoothing out irregularities and setting up the structure we see today. This idea helps explain why the universe looks so uniform in all directions and fits closely with measurements of cosmic background radiation. Quantum creation theory. Quantum creation theory suggests the universe could have formed from a tiny fluctuation in a quantum field. In this view, space and time themselves can briefly appear and disappear, and under the right conditions, one of these fluctuations could expand into a full universe. It connects modern physics with the idea that something can arise from what appears to be nothing, though the concept of nothing here is still complex. Multiverse theory. The multiverse theory proposes that our universe is just one of many, possibly infinite universes. Each one could have different laws of physics, constants, or structures. Some versions suggest universes constantly form like bubbles, each with its own beginning. This idea helps explain why our universe seems finely tuned for life, though direct evidence remains difficult to obtain. Ekperiodic theory. The Ekperiodic theory describes the universe as forming from a collision between higher dimensional objects, often called branes. When these structures collide, they release energy that creates a hot, dense state similar to the early universe described by the Big Bang. This model comes from string theory ideas and offers an alternative way to reach similar observable results. String gas theory. String gas theory imagines the early universe filled with tiny vibrating strings rather than particles. These strings interact in ways that could determine how many dimensions of space become large and visible. It provides a different perspective on the universe's origin, tying its origin to the behavior of fundamental strings rather than a single explosive event. Loop quantum cosmology. Loop quantum cosmology suggests that space itself is made of tiny discrete units rather than being continuous. In this model, the universe may not have started from a singular point, but instead bounced from a previous contracting state. This removes the idea of an infinite density at the beginning and replaces it with a transition between phases. Holographic universe theory. The holographic universe theory proposes that our three-dimensional universe could be a projection of information stored on a distant surface. In terms of origins, this suggests that the fundamental description of the universe exists in fewer dimensions, and what we experience is an emergent result. It changes how the beginning is understood, focusing on information rather than physical expansion alone.